Yeah, hi. So today's sessionలో మనం చూద్దాం PVC and storage class in Kubernetes. Okay. So I will show you. So a sample, I will take one sample application, 3-tier application, and I will show you the demo of PVC and storage class. Okay. So first, so we need to set up the cluster. Okay. So here we have bicep files. So I have already uploaded these files in my GitHub account. So here is the repository details. So I will paste the repository details in the video description. So this is the 3-tier application. So one backend, one front end, and one database. Okay. So let's create the infrastructure first. So we have two bicep files. One is main bicep file. So in this we are creating the resource group. Okay. So we are referring it from the module. So okay. So this is the module. So you can go through it once. So from this module, we are creating the resource group from main.bicep file. So you can just clone the repository and execute this command to create the resource group. Okay. You can execute this command. So it will create the resource group, and next file is infra.bicep. So in this, so we will be creating one VNet in that two subnets. So one is for VM and one is for AKS cluster. Okay, so this is the AKS module and this is the VM module. So once this is done, we can execute this one to create the AKS cluster and VM and one VNet and two subnets. And also in the VM, so I'm also installing these things. So one is Azure CLI and kubectl, Helm, and VPN also I am installing. So if it is a private cluster, you can connect to the private cluster. So by using this VM. So for that purpose, I am also set up the VPN. So inside the VM, so just you can install the OpenVPN client application. Sorry, not this one. OpenVPN Connect. So this is the client application. So you can install it and connect to your VM. So I will show you how to connect. Okay, so a resource group has been created. Next, so you can execute this command. So once go to the portal, just go to the resource group section. So here is the resource group. So in that resource group, we are creating VNet and AKS and one VM. So it will take a while. Just wait for a few more minutes. Okay, so our VM has been created. Let's connect to the VM. So just click on connect, and you can copy this. Just go to the PowerShell or any command. So you can take any terminal and just connect SSH username at the rate IP address. Just press enter and it will ask the password. You can type S hello world 3. Just to switch to the root user. So I'm also, while booting the VM, so I'm also installing this kubectl Azure CLI. So just if it is installing on, we can just check it in the logs section. So tail -f spare log cloud output. So you can see here now Azure CLI is installing. Okay, so now it is installing Helm. Okay, just press Control C. Just login into the Azure. Okay, just press type Azure login. And next it will ask subscriptions. So I will go with first off. It's clear. So now we need to connect to the cluster. Just go to the bootstrap.sh. So here we have commands. I'm also setting the alias for kubectl. Uh, sudo vi.bash rc. Here we can type alias yes equal to kubectl. Just reload the file. like kubectl get knows. Okay, so it's working. Now let's take the demo application. So this one, let's clone it. So before that, so I will check it in the VS Code. Oh, this is the stateful set file for MySQL. Okay. So in three ways we can mount the storage. One is Azure file, another one is Azure blob, and another one is Azure disk. So by using this, so I can connect this Azure disks to database, MySQL database only. And remaining two, I will show this demo by using this application, by using the front-end Nginx application, because these two are not supported for a database, or you can mount it to some other location. So by default, where lib MySQL, that is the location where the uh, data is stored, like MySQL data is stored in that location. So in that location, we are unable to mount these two files because it's a critical. So you can mount it to some other locations, like any logs location into MySQL or any database applications. Do not mount it to the actual data location. So where the data is stored for critical applications. So first we will go with the. So we have two types of provisionings, right? Static provisioning and dynamic provisioning. In static provisioning, we need to create volumes manually. Azure disk. Let's say, for example, if you take Azure disk, so we need to create it manually in the portal. So by using any bicep file or Terraform, that Cloud Engine will create or Azure admin will create. So here is the diagram. So first we need to create one storage Azure disk in Azure portal. So once you create that storage, and next you need to create a persistent volume. Okay, so it is just a wrapper of the storage. Okay, and then you need to create the PVC. And you can mount it to your manifest file. Okay, so PVC, that means it's just requesting the storage. Okay, so here is the basic diagram. You can check it once. These persistence volumes are created by the storage admin or Kubernetes administrator. Here we are requesting 10 GB and mount it to your database or backend or front end. So once you create the PVC, it will bound, it will attach it to the persistent volume. So okay, that is static provisioning. So for dynamic provisioning, we no need to create a persistent volume manifest file manually. So you need to just create a storage account, a storage class. Sorry, you need to create a storage class. In the persistent volume claim, you need to mention that what is the storage class you need to attach. So first we will go with static provisioning. So in the static provisioning, so I will be creating one Azure disk. So okay, this is the command. So if you see here, just go to the resource groups. So this is the resource group we have just created. This is the resource group. It is created automatically by the AKS cluster. So I will create disks in this resource group only. So if I create the disks in this resource group, we need to give some artwork permissions. So here is our node pool, right? So in this resource group only, I will be creating a Azure disk. So this is the here. I to mention the resource group. So if you see here, there are no disks currently present. So once you execute this command, it will be creating one Azure disk with size 1 GB. Okay, so the disk has been created. Let's check it. So once go to the Azure disks. So this is the disk. Okay, so just click on this. You can copy the resource ID. This we need to provide it in this section. We'll show you. So this one we need to paste it here in the persistent volume section. Okay, so this is the persistent volume manifest file. Here you can put persistent volume reclaim policy retain, and next volume resizing volume expansion true. So you can mention these two things in the persistent volume. So okay, just I will push this code. Okay, just you can clone this repository. Okay, just switch to that directory where you can see all the files. Here we have backend, frontend, and MySQL. So let's apply kubectl apply -f. So MySQL. Okay, namespace is not found. Let's create the namespace. And expense kubectl create namespace expense. Okay, and then execute this one. So what are the files are there in MySQL directory? It will be created. So and next kubectl apply -f no backend. You can deploy and then front end. Okay, let's clear the screen and kubectl get ports -and expense. Okay, still the container is creating. Let's describe the pod. Kubectl describe pod space pod name. No, it is running. Let's check the PV. Kubectl get PV. Okay, so this is the PV. So we have created. Okay, the reclaim policy is written. It's two types. So we have one is delete and another one is retype. So we will discuss it later. And climb is this one. So this PV has already climbed by PVC. So this is the PVC name. This is the namespace. So kubectl will get PVC hyphen expense. So you can see here it is bound successfully bounded to this PV. Okay, storage class I'm not mentioning here because this is a type of static provisioning. So if you want, you can also mention. So this is optional here. So let's check kubectl get pods. So okay, so all the three pods are up and running. Let's connect to the. Let's get the public IP load balancer. Kubectl get svc hyphen expense. Okay, so for front end we have a one load balancer IP service type. Let's access the application. So you can see. So this is the application. So here you can add some amount, 100 rupees. Okay, successfully added. So 200 rupees traveling charges. 150 for lunch. Okay, so you don't type any characters here, only numbers you can type. Okay. Okay, so this data has been stored in the Azure disk. Okay, that we have attached into the our MySQL. Okay. So PVC is successfully bounded to PV. Okay, so this step is completed. In this way, you can attach. Okay, now I want to show you one thing. Let's say, for example, if you deleted, someone has deleted PVC, how to attach it again? Okay, so okay. Just I will split this kernel. Okay, so kubectl get PVC, so I can expense kubectl get PVC. So it is stuck in the deleting mode. So because of so when you apply the PVC like kubectl apply FN of PVC, so Kubernetes by default it will add some finalizers. So You can make it null. Okay, then only the disk will be deleted. So now you can see here the disk has been deleted. Control B, arrow. Okay, now check the kubectl. You get PV. So your PV is still available. So if you make it here, delete, the reclaim policy is delete. So when you delete the PVC, the PV is also gets deleted immediately. So in this case, it's not deleted because the reclaim policy is retained. So the data is still exists in that disk only. So if you see the status is released, the previously status is bound and now the status is released. Okay, so if you want to make this available to the next PVC, the status should be available. Okay, so how to make it available? So we'll show you. So let's edit the PVC kubectl, edit PV, PVC name. So here you can see this is the claim reference. It's also already referring to the existing PVC. This PVC has been deleted, so you can delete it from the PV also. Um, 3, 4, 5, 6, 7 lines. So this. So what you can do means here again you can attach it to the PVC. Okay, so PVC has been deleted right by ourselves manually. Now we need to create the PVC. Just go to the CD MySQL. So in the MySQL.yaml file we have PV manifest is it. So let's apply that kubectl apply -f. So before that, once load the application. Okay. Uh, Before that, kubectl delete -f. So I will delete it. Okay. Kubectl reports. So I will delete the stateful set. Okay. Kubectl delete sts mysql. Okay. The stateful set has been deleted. So the backend it will go into this state crash loop backup because this backend is depending on the MySQL. So once the MySQL is available, then only this this pod will be this pod will up and running. So now let's create the file again. kubectl apply of MySQL. Okay. Oh, error. Okay. So if you see again, let's try to access the application. So here it is not showing any data. Okay. Let's wait for a few seconds. Now MySQL is running. Let's check the PVC. Let's see, it will get PVC hyphen expense. Let's delete the backend part. Let's check the status again. Let's see. Load balancer IP. So the same IP, right? So you can see here still your data is existed. So you can access your data. Okay, so even if you deleted the PVC, still you can able to access your data. So because the PV reclaim policy is written only. So if it is deleted, then you are unable to access this application, unable to access your data. Okay. So these are the rules for PV and PVC. You can just go through it. See, here is the section with why Azure Blob Storage and Azure files are not suitable for MySQL databases. So in this section where lib MySQL, so and that in that location, MySQL data will be stored. So instead of that, you can mount it to some other location, like where the logs are stored. So I didn't try this, but you can try it from your end. Just try to mount it to some other location. Let's say, so you can mount it to logs location where log MySQL. So where all the logs will be located in this location. So you can try to mount it here, Azure Blob and Azure File Storage. Okay. So now static provisioning is completed for Azure Disk. And you can see this is the persistent volume manifest file and this is the PVC. If you are stuck in deleting PVCs, so you can execute this command. And next I will show you the dynamic provisioning for Azure disks. So for that, so when you install the cluster, so by default, so all the storage classes will be available. kubectl get a C. So you can see this is for disks. So disk provisioners also disk provisioners available and file provisioners also available. So the missing thing is blob provisioner and blob storage class is not available. To enable that, so you need to execute this command. It will enable the blob drivers. Can yes, enter. So it will take a while. Okay. Now I will delete everything. It will delete ifn of my SQL. Okay, so now let's go to the VS Code. So here you can comment it PV, and this also I will comment it out. Okay, so this is the PVC. You can uncomment it. So now we are discussing the dynamic provisioning. Okay, so for dynamic provisioning, you need to create PV. Okay, so the existing PV also I will delete. So I will delete it from here. Or else I think it will be deleted automatically once you delete the PV. You can delete it from here. Okay, so now so here I am providing the storage class name default. So you can certainly get SC. Now see, the command has been installed blob drivers. Here you can see the blob drivers. Blob StorageClass also available now. In the blob, we have two types. One is Fuse and one is NFS. For NFS, you need to create a premium storage account. Okay. You can take anyone. Like so, I will take the default disk provisioner. Only disk provisioners you need to take and copy it here. So because this is a database application, so you need not to no need to mention these things. Azure file and Azure blob. Only you can mention it to default. Okay, let's push the code and pull the code. Okay, and apply. Let's check if the disk has been deleted. So again, you can apply it. So apply FNF. First, my SQL. Next, can apply backend and front end. Let's wait for a few seconds. You can see this is the PVC has been created, and PV also this is automatically created, right? So we are not creating this manually. It's created by default. It's created by, see, you can see. So the claim name is this one, PVC hyphen claim name, and this disk has been created automatically. Okay, so who created the storage provisioner is created that disk. Okay, so here you can see the reclaim policy is delete. So once you delete the PVC, the PV also gets deleted. Okay, let's check it. QCTL get site and expense. Let's take the load balancer IP. Here is the UI. Again, you need to enter. Okay, so it's working fine. You see it again. PV expense. Here we can see. So I will delete the PVC. So the PV also gets deleted. You can see here. kubectl delete PVC. So what's the PVC name? So MySQL data, right? So hyphen an expense. So if you are stuck in deleting, you can execute the command. See here, fetch PVC. So once you executed the command, the disk has been deleted. The PVC claim has been deleted. So you can check the PV also. kubectl get PV. Now I will show you the next thing. So if you go to the front end deployment file, so here we have Azure file and Azure blob storage. So I'm showing this. I'm showing this in this demo. So you can uncomment it. So this is the Nginx front end application. So I'm mounting this to the front end application. So this is the PVC for file share. This PVC is for blob storage. And this is the PV. This PV is for blob storage. Let's push this code. Let's go to here and do the git pull. Let's not deleting here. Okay, let's apply. So kubectl apply. I have front end. Okay, unchanged, unchanged. 987 did not find. Okay, the storage account has not yet created, right? Let's create the storage account and Azure file share and Azure blob. We need to create it. So here we have. Let's execute here. So it will create the storage account with that name, my storage account ESTUS. So in this resource group, so this is the storage account type standard LRS. So I am storing this Azure storage connection string. So for storage account connection string, I'm storing it as an environment variable. And Azure storage share. In this command, we are creating the file share. Next, let's go to the portal storage accounts. You can see the storage account has been created. And let's check the file share. Is it created or not? The file share has also created. Now, okay. So we are also exporting the storage key as an environment variable. So this is the storage key. So now we need to create a secret. We need to create a Kubernetes secret in that. So we are mentioning the Azure storage account name and Azure storage account key. To execute this here, kubectl create secret storage account name, storage account key. So the secret has been created. And next, so blob storage also we need to create. So in this command, storage account create, storage account has already created. Now let's create the container. I think the resource group also need to mention. Very storage account. Let's add the connection string. test container has already been created. So that's why it is throwing error or false, created false. It's already existed. Okay. So I am mounting it to the slash mount slash Azure file location and slash mount slash blob location in Nginx uh, Nginx pod. So this is the persistent volume claim. Read rate access money. This is the storage class name I am providing here. Azure file CSI. And for blob storage, and this is persistent volume for Azure file, and this is for persistent volume for Azure blob storage. So in volume handle, you need to provide storage account name and container name. And here also, we need to create one secret, right? That secret has already been created. In that secret, we have a storage account name and the storage account key. So this one, storage account key and storage account name. So we need to provide the secret name here. I think we didn't create. I need to create it in expense namespace. Okay. So this is in default namespace. Create it in expense namespace. Okay. Okay. Let's check the status. kubectl get pods f9 expense. So now all the pods are up and running. Let's get into this pod kubectl exec-80. This pod name. So f9 expense. Hyphen namespace. Okay, now we are inside the pod. Let's go to the manifest again. So here where we are mounting the file share slash mnt slash Azure file, right? So let's go to that location slash mnt slash Azure file. It's not mounted here. Okay. So let's come from the pod and restart it again. kubectl restart and this is a kind deployment, right? So now let's get into the pod once. comment this out, push the code again. Let's pull the code again. Now apply it again. Okay, kubectl. Now let's restart the deployment. Okay, so kubectl reports happen expense. These are the mounts successfully mounted at this mount point. Let's go to the Azure file once. So here you can create directories like let's say I'm creating so to be today's date. So 18, then 25. Okay, so here we have created. Let's go to the Azure portal and file share. So there you can check. So this is the file share. Let's go to the browse section. So here you can see the directory has been created successfully. So we have created this directory inside the pod. Okay, but it has created in the Azure file share. That means the mount has been successfully mounted to the Nginx pod. Okay. So now I will create the same folder in Azure container. Let's go to the container. So here you can see no items. So I will create. Okay, so now I will create the same folder. Okay, I'll go to the Azure portal and just refresh. So now you can see the directory has been created. Now inside this directory, let's try to create files. File 1, file. It's not visible here. Let's go to the file share. So here I will create. Let's go to the file share. Just click on browse. Just get into the folder. So here you can see file 1 and file 2 has been created. Okay. So I have mounted it to some other location /mnt, or else you can mount it to Nginx logs location. Okay, so where log Nginx, I think. So this is the location where the Nginx logs are present and error logs also. So in this location, you can mount it to the file share or Azure Blob Storage. So you can see all the logs here. Yeah, that's it for this video. I hope you understand. Let's check it if anything is missing. So these are the three types. We have our reclaim policies: delete, return, and recycle. So this recycle is already been deprecated. Currently, we have return and delete. So Azure file share and blob storage is for best suitable for shared data access, like for to access the logs, to access the application logs, right? So at that purpose, for that purpose, you can use Azure file share, and Azure blob storage is for to store the object files, like any type of file, right? You can also store text files and video files. So Azure disks are only for high performance. You can attach it to any critical applications like database for that purpose. Let's say example. So if you purchase any electronic appliances, right? Let's say initially they will provide a 1 year warranty. If you want to extend it to 3 years, they will ask you to upload the bill into their website. So if you see in their website, the endpoint is connected to the some other blob storage or AWS S3 bucket. Okay. So you are uploading your purchase bill into the blob storage. So that is one of the real world example. Okay, thank you. That's it for this video. Thank you. Bye.